Hello friends, good morning to you all. I am Dr. Ranjit Dhunde. In the last lecture, we have already discussed application of De-Moivre's theorem. In today's lecture, we will solve one more problems based on the De-Moivre's theorem. Now, example 1, use De-Moivre's theorem to solve the equation x to the power 4 minus x cube plus x square minus x plus 1 equal to 0. Now degree of this equation is 4. Now therefore this equation has 4 required roots. Now solution of this given equation. Now multiplying this given equation by x plus 1. We get x plus 1 times this LHS part x to the power 4 minus x cube plus x square minus x plus 1 is equal to x plus 1 times this 0, answer is 0. Now here this x plus 1, this is not the part of the given equation. Now therefore x equal to minus 1 is not the solution of the given equation. Now simplification of these two terms. Now x times this bracket plus 1 times this bracket. Now x times this bracket. X times x to the power 4, answer is x to the power 5. X times minus x cube, answer is minus x to the power 4. X times plus x square, answer is x cube. X times minus x, answer is minus x square, plus x times this plus 1, answer is plus x. Now 1 times this whole bracket. The 1 times x to the power 4 plus x to the power 4. Now 1 times minus x cube, answer is minus x cube, plus 1 times this x square, answer is plus x square. Now 1 times this minus x, answer is minus x, plus 1 times plus 1, answer is plus 1, and this is equal to 0. Now here this minus x to the power 4 plus x to the power 4 get cancelled. X cube minus x cube get cancelled, minus x square plus x square get cancelled. Similarly this plus x minus x get cancelled. Now therefore remaining terms are x to the power 5, this plus 1 is equal to 0. Now degree of this new equation is 5, and therefore this new equation has 5 required roots. Now we write this equation as x to the power 5 is equal to minus 1, that is x is equal to minus 1 to the power 1 by 5. Now we write this minus 1 in trigonometric form. So therefore this x is equal to, now this cos pi be the minus 1 and this sin pi be the 0. So therefore this cos pi plus I sin pi is equal to minus 1. So therefore this is x is equal to cos pi plus I sin pi to the power is 1 by 5. Now in general form this x is equal to, now we recall the formula cos theta plus 2k pi is equal to cos theta if k be the positive integer. So therefore we write this cos pi as cos pi plus 2k pi, plus similarly we write this sin pi as sin pi plus 2k pi, here k be the positive integer, to the power 1 by 5. Now by using De-Moivre's theorem, cos theta plus I sin theta to the power n, answer is cos n theta plus I sin n theta. Therefore by applying De-Moivre's theorem, cos, here pi be the common term, 1 plus 2 times k times pi upon this 5, plus I sin 1 plus 2 times k times pi upon this 5. Now degree of the new equation x to the power 5 plus 1 equal to 0 is 5. Now therefore this equation has 5 required roots. Therefore substituting k equal to 0, 1, 2, 2, 3, 4. Now by substituting k equal to 0, we get the first value of the new equation. So we denote it is by x1. Now this is equal to cos. Now k be the 0, the answer be the pi by 5 plus I sin pi by 5. Now by substituting k equal to 1, we get the second value of the new equation. That is denoted by x2, and this is equal to, now k is 1, that in 1 plus 2 times 1 means 1 plus 2 be the 3 times pi by 5. The answer is cos 3 times pi by 5 plus I sin 3 pi by 5. Now by substituting k equal to 2, we get the third value of the new equation. Now k be the 2, the 1 plus 2 times 2 means this whole answer be the 5 by 5 1. Therefore this whole answer be the cos pi. Therefore x3 is equal to cos pi plus similarly I sin pi, this is equal to minus 1. Now by substituting k equal to 3, we get the fourth value of the new equation. It is denoted by x4. Now this is equal to cos. Now again here k be the 3. The 2 times 3 6 plus 1 7. The answer is cos 7 pi by 5 plus I sin 7 pi by 5. Now by substituting k equal to 4, we get the last answer of the new equation. It is denoted by x5. Now this is equal to, now k be the 4, the 2 times 4 8 plus 1 9 pi by 5. So cos 9 pi by 5 plus I sin 9 pi by 5. So therefore x1, x2, x3, x4, x5 are the roots of the equation x to the power 5 plus 1 equal to 0. Now excluding the answer x3 is equal to minus 1, because excluding the value x is equal to x3 is equal to minus 1, because as we multiply given equation by the factor x plus 1, therefore required roots of the given equation are x1, x2, x4 and x5. Therefore x1, x2, x4 and x5 be the required roots of the given equation. Hope all of you have understood this problem. In the upcoming lecture, we will solve more problems based on the De-Moivre's theorem. Please subscribe the channel and let me know your comments and feedback. Thank you.